Hello and welcome. In this video, we are going to solve problem number 19 of Leetcode, that is remove nth node from end of list. So in this problem, we have given a linked list and we have to remove nth node from the end of the linked list, and then after we have to return head. So let's say we have given a linked list as 1 2 3 4 5. You can see it is already drawn here, and if we are and n equal to 2, so if you are finding the nth value from last, so this is the first value from nth, uh, from end, second value from end, third value from end, fourth and fifth value from end. So in this case we have to return second value, so this is the node that you have to delete. So after deleting this, our linked list will be something like this: 1 2 3 and 4 will be removed and 3 will be pointing to 5. So we have to delete nth node from last. So for the second test case, it has been given one only node, and we have to delete the one first node from last. So if we are deleting it from last, so this is the first node that last, it will be deleted, then our linked list will be only null, so we have to return empty linked list, that is null. So in this case, in test case 3, we have given a linked list 1 2, and we have to delete first node from last. So this is the node that we have to delete. After deleting this, our node will be this. Okay, so this is what we have to return. So now we have understood the question. Let's see how we can solve this. So the naive approach that we can follow in this problem is going to be something like: we have to first find out how many nodes we have already in our current linked list. So for that we will be iterating, iterate through iterate through all the node, and then find number of nodes. This will be our first step. Okay, so after iterating through all the nodes, we have to find number of nodes. So let's say it is going to be count, and then we have to update in second step. We will be update our n by count minus n. So let's say at starting our node is going to be 5, and we have to delete second node from last. So after counting this, our count will be 5. So we will be updating our node n equal to count minus n. So our node will be, our n value will be 5 minus 2, that is 3. So we have to traverse three step: one step, two step, three step, and then after which will be node, whatever node will be, we have to delete that. Then after, in step 3, delete next node and return head. So in this case, what is the time complexity that this algorithm is going to take? So in first step, it is going to take big O of n for iterating all the nodes, and then we have to iterate through all the nodes for for deleting the element. And let's say our given value of n is 1, so in this case we have to iterate throughout all the nodes. So in this case it is also going to be big O of n. So overall time complexity is going to be big O of n plus big O of n, something like big O of 2n. Okay, so this will get accepted if we are going to submit this solution. But can we optimize this? Yeah, we can. How we can? Let's see. So rather than moving our nodes for two time, we will be trying to solve this in big O of n, that is in one iteration. Let's see how we can do that. So we will be making two pointer. One pointer will be fast and another will be slow. We will be moving our fast pointer, let's say 1 2 3 4 5 6 7. These are the nodes. Okay, and n is going to be 2. In this case, we will be moving our fast pointer by n times. So our fast pointer will be 1 2 here, and then after we will be moving our slow and fast simultaneously from here. So our fast will be here and slow will be here. So we will be moving total till our fast will be reaching the last index. So in this case, so slow will be here. Now if we are moving one time, then fast will be here and slow will be here. Then again we will move one time, fast will be here, slow will be here. Again we will move one time, fast will be here, slow will be here, fast will be here, slow will be here, fast will be here, slow will be here. Now our slow will reach to fifth position, and our fast will be reached at last position. So in whenever we will find out that our fast has been reached till last position, we will stop iterating, and the next index that is pointing to slow is going to be our node that we have to delete. So in this case we are going to delete this next slow equal to slow equal to slow dot next equal to, so we will be pointing slow dot next equal to slow dot next of next. So slow dot next. So we are pointing this fifth index from fifth to 7. So what we are doing, we are at first we are moving our first pointer by n size, and after moving it by n, our first pointer will have already traveled n distance, and then we are simultaneously moving slow and fast. So whenever we will reach till last using fast, if whenever our fast pointer will reach till last, our slow pointer will be at the node that we have to delete. So in this case, our slow pointer it is node 5. So we have to only delete the next pointer, and we have to return the result. So what is pseudocode for this? What is the pseudocode for this? Let's write down the pseudocode for same, and then after we will be writing the code for same at compiler. So first we have to yeah first we have to create a dummy node, that is temp, which is going to be list node of 0 or empty, whatever you want. And then in temp.next we will be assigning our head. Okay, and then we will be creating two node, slow equal to temp and fast equal to temp. Now we will be moving our fast pointer from I equal to 0 to n. We will move our fast equal to fast dot next, and then we will be running a while loop till our fast dot next is not equal to null. So we'll running our while loop until our fast will reach till last node. Okay, so inside this while loop we will be running our fast by one step, fast equal to fast dot next, and slow is also running by one step. Okay, then it after doing this, our slow will be at this point, something like 3. So if you are running our fast and slow simultaneously, where fast is already traveled n distance earlier, so in this case fast will be something like here, and slow will be something like here. So now we have to only do what? Slow equal to slow dot next equal to slow dot next of next, and then return temp dot next, as we had pointed our head at the next index of temp. Okay, so this is the pseudocode that we have to write in our compiler. Let's go to the compiler. So first create the dummy node. Okay, now in temp of next we will be putting our head. Now create two node for slow and fast. We'll be running our fast pointer initially for n times. For this we will be doing fast equal to fast.next, and then we'll be running our slow and fast simultaneously, while fast.next is not equal to null. Okay, so slow will be slow.next and fast will be fast.next, and at last we will be doing slow.next equal to next of next. Okay, as we have pointed our head index at the next of the temp, so we will be returning temp dot next as our head pointer. Now run this. Okay, so first test case has been passed. Check remaining two. Run this again. Okay, now submit this. Yeah, our solution has been accepted, and this is one of the optimized approach that we can come up with. I hope you must have learned something from this video. In this case, please make sure to like the video, subscribe to the channel, and if possible, please share this video among your friends. Thank you.